And in this section, we'll talk about graphing lines, intercepts, slope, and equations of lines. All right, so some basics to get started. One of them is we'll get started by talking about what's called the coordinate plane. All right, so let's draw it out like this. And I'm going to assume that you don't know anything about the coordinate plane. So this will probably be review for some of you. How many of you have never seen this before? Okay, you're in for a treat. So when we have a coordinate plane, it's just a way to organize numbers. First thing is, let's talk about this being the x-axis. The x-axis always goes horizontally, left and right. And then the y-axis goes vertically up and down. I had a graduate class professor that said Y rhymes with sky. Sky is up. Okay. We could also label each of these four sections in the coordinate plane. This quadrant right here is called quadrant 1. This is called quadrant 2. This is called quadrant 3. And this is called quadrant 4. You can see that they're labeled counterclockwise. And then as far as where the points go, you could label this like 1, 2, 3, 4. Obviously, it keeps going up like that. This is in the negative direction. Maybe we'll just go 4 units in the negative direction. Kind of like a number line. And we could also label points going up and down. So going up, we'll just, again, label 4 points going up, 4 points going down. So in quadrant 1, any point that's in quadrant 1 would have a positive x value and a positive y value. The x value always comes first, the y value comes second. Quadrant 2 is we have negative and then positive. Quadrant 3 would be both negative. And then quadrant 4 is positive and then negative. All right, so what we're going to do to just practice this is we're going to plot the ordered pair. And then we're going to state the quadrant or axis. Okay. And these will be our examples. So what I'm going to do, just to make it a little more organized, I'm actually just going to move this. You could leave your notes alone if you already wrote that. But to make things a little bit more clear, I'm going to organize my notes like this. I'm going to draw a coordinate plane. And then I'll give you some points to graph. We're going to label this from 1 to 5 in each direction. All right, so start with the point 2, -3. All right, so what we're doing is on the x-axis, we're going to go to 2, y-axis, we're going to go to -3 and put a point right there. That'll be 2, -3, and that's in quadrant 4. Okay, easy enough. What if we had a point where it's 3, -2? No, let's do -3, +2. So you go -3 on the x-axis and then up to +2. That would be this point right here. And that's in quadrant 2. The point 6, 1 would be over here somewhere. Right, you go 6 on the x-axis and then up 1. That's in quadrant 1. The point -2, 0. Remember, x is -2, y is 0, so that would be right here. That's along the x-axis. And then if we switch the points, use a rainbow color. All right, so let's say 0, 2. 0, 2 is right here. All right, and that's along the y-axis. So that's our coordinate plane and how we label points. Next thing is we'll state the coordinates what I'll do is I'll put a handful of points on the graph, and then you just tell me what the coordinates are. Again, let's make a graph, go 5 units in each direction. And I'll put a point right here. That point's going up and down, so it looks like the x is 0, the y value is 3, so we just label that point 0, 3. If I put a point right here, that would be when x is 4 and y is 0. Point right here is at -4, 1. It is possible to put a point at 0, 0. That point's called the origin. I think you get the idea with those, right? All right, keep going. What if I said the table shows expected height versus age? And I'll give you column with age, and I'll give you a column for height. Height will be in inches. And let's do 2, 4, 8, and 13 for the age column. And then for height, let's do 12, 18, 40, and 50. I'm going to ask you 3 questions. First question is, we'll write this as ordered pairs. And just looking at this chart, it looks like, I mean, the age doesn't depend on the height. That's kind of silly. And, you know, how tall you are is based on your age. So in math, we would say that age is the independent variable, or that would be the x. And height depends on age. So height would be the dependent variable, or we would just put y. So if we were going to write this as a list of ordered pairs, what you would do is put a little bracket like this, and then we'll put 2 and 12 together, 4 and 18 together, 8 and 40 together, and then 13 and 50 together. Second question is, what does the point 4, 18 mean? Well, this just means when a child is 4 years old, their height is 18 inches. And the last question would be, what is the trend? Anyone want to answer that? If you look at the table and the points, what does it look like? Yeah. Yeah, the older you get, the taller you get, right? Very good. We could just say that. Or as age increases, height increases. That's because age is called the independent variable, and height is the dependent variable. So independent just means age will change, and then based off of your age, your height is whatever it is. A couple more types of questions from this section. Let's complete the tables. I usually draw my t's with a little tail on the end. That way they don't look like a 1 or an I or something like that. I'm going to give you 3 tables, and I'm just going to ask you to fill in for the missing pieces. First table, it says y is equal to 2x. And we have an x and a y column. I'm going to put 3 rows. We're going to do 3 of these, so if you just want to make sure you have enough space for 3 tables, that'd be good. And in the table, we'll put a -2 here, an 8 here, and a 3 there. And we just want to find the missing piece. Well, for this first row, it's telling you x is -2, figure out where y is. So if y is equal to 2x and x is -2, y would be -4. For the second blank, again, if y is equal to 2x and y is 8, you could just replace that. And now we just have to solve for x. The way you solve for x is you divide by 2. And you get x is 4, or we could just write x equals 4. It's called the symmetric property in math that you could say 4 equals x or x equals 4. It doesn't matter. But we could just plug 4 right here. Then we're going to do the same thing for this third column. Again, if y is 2x and x is 3, 2 times 3 is 6. Okay, so that's our first example. Second example, let's use the equation y is equal to -1/3 x. And if you could again draw a table with 3 rows and 3 columns. And let's plug in numbers here. We'll say x is 3, x is 0, and x is 12. And we'll do the math on the side and figure out what goes in the blanks. So if y is -1/3 x and x is 3, -1/3 times 3 is -3/3 or just -1. You could also use that $10 calculator I recommended. -1 would be the y value. If x is 0, you get y is 0. And then if y is 12, we have to divide by a fraction. So in math, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So what I mean by that is, if we divide 12 by -1/3, what we'd get is x is equal to 12 divided by -1/3, or 12 times negative 3 over 1, which is negative 36. So we change division to multiplication, and then we multiply by the reciprocal, which is just the flip of the fraction. So x would be negative 36. And I have another table. Let's say 2x plus 3y equals 6. And I'm going to use 1 for x, negative 2, and then 0 for y. So we'll do this much the same as the other ones. Let's write the equation, and then we'll plug in for what we have and solve for what we need. So if x is 1, we're just going to plug 1 in for x. 2 times 1 is 2. And now we're just looking to get y by itself. So we could subtract 2 on both sides. And we get y is 4/3. And like I said before, you want to leave it as 4/3. You don't want to convert that to a decimal. You don't want to write 1.3, and you don't want to say 1 1/3. Just leave it as 4/3. Next is when y is negative 2. So we get 2x plus 3y equals 6. Y is negative 2. So let's just make sure we plug it into the right place. Add 6 to both sides. And then divide by 2. We get x is 6. And the last one we have is when y is 0. So 2x plus 3y equals 6. Plug in 0 for y. We just get 2x is 6. We divide by 2. X would be 3. That would be that. All right, one more example for this section. All right, so let's say the cost to build chairs is given by y is equal to 20x plus 1,500. And there's going to be 2 questions. The first question is to complete the table. And second question is find the number of chairs that can be made for $2,000. My table is going to have an x and y, and then x is 100, 200, and then 300. And remember, y is the cost, and x represents the number of chairs. So this is similar to what we've been working on, except it's more of an application. We'll just replace x with 100, see what y is. Do the same thing with 200 and 300. All right, so first let's do it if x is 100. If x is 100, we're just going to do 20 parentheses 100 plus 1500. On your calculator, if you type it in exactly like that using parentheses, we'll get the answer. So 20 times 100 plus 1500 is 3500. So that's how much money it'll cost to make 100 chairs. If x is 200, $20 times 200 plus 1500 is 5500. And then if x is 300, 20 times 300 plus 1500 is 7500. And then to finish us up, how many chairs could be made for 2000? Well, 2000 is the cost. So if y is equal to 20x plus 1500, and the cost is 2000, now we just have to solve for x. The tricky part with a problem like this is making sure you plug it in for the right variable. If you put it in for the wrong variable, you'll get it wrong. So subtracting 1500 because we want to get x by itself. And dividing by 20. We get x is 25.